this is part 4 of chemistry. We're studying the unit 1 of class 11th. So earlier we left at the 7 base units, right? So when we say 7 base units, these are the fundamental units. Fundamental is something that is basic, that is independent, and we further move on from it and derive other units. So we can see that fundamental units are basic independent units. And we have those 7 base units, right? All the other units can be derived from it. For example, when we derive units, one example, if we talk about volume, it is length cube. Which can be meter cube. Okay. Small thing that I want to point out is that when we talk about the historical development, we started from small measurements, reference measurements, be it the size of the foot or the body weight for length and weight, right? And then we had the metric system, but we wanted a system that is universally accepted. We already had metric system, we already had gram, kilogram, but when we look for something which had a standard reference, when we say standard reference, we have all the standard references for meter, kilograms, second, ampere. All those definitions are presented in NCERT. For example, for kilogram, earlier it was platinum iridium cylinder. So that was something that was not reactive and its weight would not change over time. So that was a good standard reference. So based on the standard reference present, we had the SI units. So when we look at kilogram, there can be a bit confusion that kilo, a prefix is present in front of gram. So how is this a fundamental unit? It is a fundamental unit because it has a standard reference present for it. Okay. Moving on, we have mass and weight. When we talk about mass of a substance, it is the amount of matter present in it. Amount of matter present in it. And when we talk about weight, it is the force exerted by gravity on an object. Okay, so mass and weight is not the same thing. Mass is constant because the amount of matter present would be constant, but weight differs from place to place because the force of gravity would differ. The SI unit of mass will be kilogram. And for weight, it's Newton. Normally, when we perform reactions in laboratory, we don't take kilogram, we take gram, because that's a smaller amount that can be easily handled. Now volume. Volume is length cube, right? A common unit for volume is liter. It is not an SI unit, but it is used for measurement of volume. Now, how do we define liter? Okay, so if you take a cube of side 10 centimeter and you calculate its volume, it would be 10 centimeter cube 100 thousand centimeter. This is the definition of liter. 1 liter. Also, if you take a smaller cube out here, of size 1 centimeter, the volume would be 1 centimeter cube, that is equal to 1 ml. But you need to know this relationship, because there is a relationship between liter and centimeter. When we perform unit conversion is done between units that have relation between them. So I'll tell you a trick. These milli, centi, deci are this prefix. Meter is unit, right? So when you convert meter into centimeter, you multiply it by 10. And in decimeter we multiply it by 10, and centimeter again by 10, so it would be by 100. Let's just set 10 out here, and another 10 for milli, so it will be 1000. Right, multiplication. And when we convert meter into deca, meter, hectometer, or kilo, we divide by 10. So if you need to convert 1 meter into centimeter, 1 meter into centimeter, we'll multiply it by 100, so it would be 100 centimeter. And if you need to convert 1 centimeter into meter, you'll divide it by 100, so it would be, this meter is a unit, right? The same can be done for liter and prefixes. Liter into deciliter, centi, milliliter, we'll do multiply it by 10, and out here you'll divide by 10. And for gram also, you multiply it by 10, and out here you divide by 10. But you need to understand that the relation out here is like this only. You don't convert liter into centimeter like that. The relationship is like 1 liter is equals to 1000 centimeter cube. So you can make conversion out here. If you need to convert centimeter into decimeter, okay, for 1 centimeter it would be divided by 10 and it's cube, so it would be divided by 1000. It would be 1 decimeter cube. You can convert centimeter into decimeter. You can convert liter into let's convert it into milliliter, okay. So if you convert 1 liter into milliliter, it would be 1000 milliliter. Like that you can convert. This is important to know because when we talk about density is the amount of substance, amount of mass per unit volume. Kg per meter cube. But in lab we don't use kilogram and meter, so it's gonna be gram per centimeter cube. This is just based on definition. It's not like kilogram per meter cube is equals to gram per centimeter cube, because normally if you convert them, kilogram into gram, it would be into 1000, and out here it would be 10 to the power 6, right? So there will be 0.0001 gram per centimeter cube. Right. Okay. Next is temperature. There are 3 common scales for temperature. We have Celsius, Fahrenheit, and Kelvin. Kelvin is the SI unit. If you look at the scale of Celsius, it's from 0 degree Celsius to 100 degree Celsius. 0 degree Celsius is the boiling point of, it's the freezing point of water, and 100 degree Celsius is the boiling point of water. In between we have 25 degrees Celsius and 37 degrees Celsius. 25 degrees Celsius is the room temperature and 37 degrees Celsius is the human body temperature. Same way in Fahrenheit scale, the scale is from 32 Fahrenheit to 2.2 degree Fahrenheit. Freezing point of water, boiling point of water, room temperature, and human body temperature. And the scale for Kelvin is from 273.15 Kelvin to 373 Kelvin. It's from 298 Kelvin is the room temperature and 310 Kelvin is the human body temperature. When we the relationship between these scales and the conversion goes by Fahrenheit is equals to 9/5 Celsius plus 32, and converting Celsius and Kelvin 273.15. Like that you can convert these scales. The negative scale is only possible in Celsius scale below 0 degree Celsius. The negative scale is not possible in Kelvin. Now, dimensional analysis is not usually used for unit conversion, but let's just go through it. It's called dimensional analysis, factor label method, or unit factor method. So we know that 1 meter is equals to 100 centimeter, right? So 1 meter divided by 100 centimeter is equals to 1, and 100 centimeter by 1 meter. So this would be a unit factor relationship. But normally we have already looked at how we can perform unit conversion. So that's it for part 4. Let's continue in the next series.